So.
All right, folks, we're going to start the next panel. So if you could make your way back to your tables.
Do you want me to sit down now?
Yeah, I think so. Do I go up?
I think so. Yeah, I think he told me to sit down, so I'll follow him here.
I was reminded by the local, so I do not hail from Boulder. And so I was reminded by my local colleagues to make the public service announcement that if you are not from Boulder, you may want to deliberately drink more water than you normally intake. So that was a good point, good reminder. All right, our next panel is going to be led by my colleague Brent Nelson. Brent is a PhD in Senior Energy Analyst with Ascend, providing utility clients expertise in demand management, resource planning, and renewable integration. Brent has extensive experience in the energy sector with energy systems modeling and holds a PhD and Master's in Science degree in Mechanical Engineering from Georgia Institute of Technology and a Bachelor's degree in Mechanical Engineering from the University of California, Berkeley. Brent is this is the interesting factor, he is a former lifeguard and wakeboard instructor, an avid general hobbyist. Currently, he toys with playing banjo. So with that, I'm going to turn it over to Brent.
Thank you. So this panel is the Power Planning Modern Complexities panel. So I want to start off with just a couple of slides about what are some of the things that make current power planning have modern complexities. And so the first one that I want to show, just real briefly, is one that we've probably seen before, either today or yesterday, or maybe elsewhere, showing very, very low PPA prices for wind and for solar. And so these prices coming very low have impacts on wholesale markets. This is a plot of hourly day-ahead power prices as a function of renewable penetration. On top is SPP, on the bottom is Europe. And you can see that as those penetrations get higher and higher and higher, those prices get lower and lower and lower, crossing negative. At the same time, we also have to manage variability. So this is a plot of a couple of different years of wind power outputs, showing significant variation both within a day as well as from year to year. And so the question becomes, how do you plan for a power system with zero or low-cost renewables entering the wholesale markets, as well as variability in output, and how do you count on that, how do you rely on that, and how do we plan in a world where these become a bigger part of the picture. So that's just a little intro, which brings me to our first speaker, which is Mark Dyson from Rocky Mountain Institute. Pull up his little bio. So Mark Dyson is a principal with the electricity practice at Rocky Mountain Institute, where he has worked since 2008 and currently leads RMI research and collaboration efforts around the roles that renewable and distributed energy resources can play in grid planning and economy-wide decarbonization. Mark received his bachelor's in computer science from Carleton College and his master's in the energy and resource group from UC Berkeley. The floor is yours, Mark.
Great, thanks. Do I need a clicker to advance the slides?
Yes.
Wonderful.
Blink.
Thank you for having me. Really looking forward to the discussion today. For those of you who don't know, RMI is a nonprofit organization. We have most of our staff here in Boulder. We do work that is both philanthropically funded on the research side, and then we partner directly with utilities, states, other private businesses to do direct support for things that are mission aligned for us, which is driving market-based solutions for clean energy. So the thesis of my presentation today is that renewables and storage are about to do to most natural gas what gas has already done to coal in the power sector in this country. So the story that I want to tell you is based off of a paper we just released and some thinking we've been doing for the past couple of years on what some of the changes that Brent laid out in power markets look like for investment decisions that utilities and IPPs are making in the next 5 years. So if we recall maybe 5-10 years ago, there was a narrative about natural gas being the bridge fuel, right? We recognized that for climate and cost reasons, coal was on the way out. And this is what the natural gas bridge looks like in 2019, where there are about $70 billion worth of new gas-fired power plants on the drawing board and sited for construction in the next 5 years that have not yet begun construction, and about $20 million more that are not shown on this map, at least, that are part of long-term integrated resource plans from vertically integrated utilities in the Southeast or other parts of the country. So this is a very wide bridge, right? And it's expected to be a very wide and long bridge. And I think the argument I'm trying to make is that that is no longer the case. We build power plants to provide three things to the grid, right? We want energy every month in approximately the right amounts and at the right times of day. We want peak capacity for when the sun doesn't shine and the wind doesn't blow to keep the lights on. And we want ramping or flexibility capacity so that we can adapt to changes in load and changes in renewable supply. So speaking generally, and I know this is an audience of experts, so I'm just going to caveat that. Speaking generally, most gas plants in this country are being proposed to fill different proportions of these three different kinds of services, sometimes in response to a coal plant retirement, sometimes in response to expected load growth. But basically, we can categorize the services required from new power plants on the margin of today's system according to these three metrics. And what we did in this study that I'm referring to is we looked across all of the plants in the United States that have been proposed for construction and figured out or estimated what is the requirement for energy, capacity, and flexibility that each of these plants would be required to meet. And then we ran an optimization model that said, how could I do that with something else? As a thought experiment, and as I'll get into, as kind of a market-based proof point for what's going on more broadly. So walking through the charts here, the red lines for gigawatt hours, megawatts, and megawatts per hour of flexibility correspond to what a typical gas plant might provide. And we're using the example here from the western United States, and I won't name names to protect the innocent. And what we've done here in the colors is stack up the different kinds of clean energy resources that could meet some of those same services. So efficiency, wind and solar on the energy side, demand flexibility, and then efficiency, storage, wind and solar on the capacity side, derating those other resources based on how much they can provide on peak or on peak net load. And then ramping and flexibility, where solar actually hurts on the West Coast because it would increase the duck curve effect, but some of these other resources can step in and provide some ramping and flexibility capacity or shape benefits. So what we call these is clean energy portfolios. And I don't claim it's a perfect term, but it's a term of art that we coined last year, and I'm going to stick with it for now. The building blocks of clean energy portfolios have gotten cheaper much faster than anyone has predicted. So Brent teed this up. I'm not going to spend a lot of time on this slide, but this shows expert projections in each year from 2009 to 2017 of the price of utility scale solar on a dollars per megawatt hour basis versus the benchmark US price from Lazard. So we started at $400 a megawatt hour 10 years ago. We're down below 50. Everybody, including RMI, that tried to forecast that price was wrong, and wrong in the same direction, too conservative. So this is some of the reason that's driving increased attention to clean energy portfolios. This chart shows in green circles, which are hard to see, but if you squint your eyes, you can tell most of them are on the coasts, what we call the state of the market for clean energy portfolios in 2018. And what I want to do now is show you what's happened since 2018, just in the past 16 months, where utilities or regulators have looked at the capability of alternate kinds of resources, clean energy portfolios, to offset thermal generation, mostly from new gas power plants. So we've seen quite a bit of development in California. Mark Young just talked about the Glendale experience. We've seen quite a bit of development further afield in the West, including PacifiCorp's most recent IRP, where they announced a significant amount of coal retirement and very little new gas to complement new renewables and storage. Of course, Xcel Energy's Colorado Energy Plan here in Colorado. And then I'm going to click through a couple of these because some of these stars represent regulatory decisions where it's not just the utilities, but the regulators are taking notice. So now in Indiana, Minnesota, and Rhode Island, state-level PUCs have denied requests to purchase or build new gas power plants as a result of some of the cost dynamics that I'm about to walk through and some of the risks associated with investing in natural gas given the falling prices of renewables. So the core finding of our study that we released last month is that if you look at across all approximately 90 proposed gas-fired power projects that have yet to begin construction in the United States but are slotted for COD within the next 5 years, 90% of that capacity would be more expensive to build than an equivalent clean energy portfolio that could provide the same energy, capacity, and flexibility to the system. So the graph here shows basically a percentage on the y-axis of cost, net present value of cost, and then a megawatts on the x-axis. And wherever one of these bars, which represents a gas plant, is below that 100% line, the clean energy portfolio is cheaper by that fraction. Whenever it's above, it's more expensive. A couple of things to note from this chart. The projects that look the best here are combustion turbine projects that we estimate would be run at a very low capacity factor as more backup resources. I'll talk about this in a minute. We see that these resources, when you look across the patch of proposed gas-fired power plants, these are the ones that are hardest to beat with clean energy portfolios, because they are going to run when the wind doesn't blow and the sun doesn't shine, right? And so clean energy portfolios that are built to compete against that kind of plant have a really hard time with today's technology. So that's why I said most in the thesis of my title. 90%, most of those high capacity factor combined cycle projects that are slotted in essentially as coal replacements, those are the ones that are most at threat. This is a snapshot of what it's looked like, and I think Chris Neller might have shown this slide yesterday, so I apologize if I'm duplicating. But the blue line is the price of a clean energy portfolio from 2010 through the present day, 2019. We've drawn a vertical line there. That represents an 80% price drop, driven mostly by solar and batteries coming down in price. And then the plateauing savings from here on reflect us using relatively conservative analyst forecasts of continued price drops for solar, storage, and wind. And then the orange lines represent, at the top, the new levelized cost to build and operate a new gas plant. And then the dashed line is just the variable O&M and the fixed O&M and the fuel to operate an existing gas plant. And the point here is that we crossed the line last year of where it's cheaper to build a clean energy portfolio than a typical combined cycle. And within the next 15 years, we're going to cross the line where it's cheaper to build a new clean energy portfolio than it is to operate at its expected capacity factor an existing combined cycle gas plant. So those are those two tipping points, those two line crossings that I've reflected in the chart here. So what does this look like for the fleet of natural gas in this country? The graph here shows the percent of proposed combined cycle projects that would be more expensive to continue operating in each year than a new build clean energy portfolio. And the finding here is that by 2035, that's about 90%. So by 2035, 90% of capacity proposed for construction will be more expensive to run than an alternative will be to build, using, again, that central forecast for the price declines of solar plus storage. And again, the backup generation, the stuff that's expected to run at lower capacity factors in regions with longer peaks or perhaps with transmission constraints, those are the plants that are harder to beat. If you add $50 a ton of carbon pricing to this, that stranded asset timeline, and I say stranded asset timeline because that's what might happen to a regulated utility or perhaps an IPP who builds these with an expectation of a certain capacity factor, that timeline accelerates by about 10 years. So how do we fix this problem? So the first recommendation is to do exactly what the last panel talked about. Run really good all-source procurement so you know exactly what you're buying and why from the market. And the second point is to not bet against innovation. Disruption happens. Think about coal plant operators 10 years ago, 20 years ago. Were they planning on shale gas? No. Think about what gas plant operators are facing in a parallel decision process today. The second point, small is profitable. We see a building trend towards investing in not big, lumpy billion-dollar combined cycle plants, but smaller units or smaller solar projects or smaller storage projects that can be built incrementally and adapt to changing loads or to changing prices in the market. So small investments can be more profitable. And then time bound the risk. We've also seen some momentum towards shortening amortization periods, or as we saw in the last panel, shortening PPA periods to try to limit some of the exposure to changing market prices that could threaten the economics of a new gas project. So I'll leave it at that and looking forward to the conversation.
Thank you, Mark. Our next speaker is Pat O'Connell. Pat is a senior policy analyst in the Western Resource Advocates Clean Energy Program.
Based in Santa Fe, New Mexico, he works to create environmentally and economically sound energy solutions throughout the interior West and has extensive experience with electricity utility resource planning, expert witness testimony, and public participation processes. The floor is yours, Pat.
Thank you. Happy to be here this morning and sharing my perspective in 6 short months. Reflecting about this, I moved from the side of the ledger where I was the stump on the chump to now I'm one of the unrulies attending these planning meetings. So I thought it would be, I had faith and trust in this conference that we would touch on a lot of the deeply technical complexities of supply planning, and we've done that. So I thought I would talk about one of the ancient complexities and give kind of what I see as the modern version of that complexity. And high level, that's just the people that are involved in the process. Okay, so this is the way I describe it is resource planning where it feels like if you're a planner that frequently you'll find yourself shouting across a gap. So, what is that gap? For me anyway, the gap was what is the point of doing a resource plan from the point of view of the entity doing the plan versus what does the stakeholder community want out of that plan? And my belief is they're two very different things. So, just to dig in a little bit about what a resource plan is, I know that this room has a lot of folks who've done resource planning, so I'd love to hear if I'm meeting what you believe or have experienced. And then on the other side of it, if you haven't been involved in doing resource planning, I'm hoping some of this will be the ignore the man behind the curtain type things that you might have experienced while you were participating in resource planning. But resource planning by the person doing the planning, what it is really just a near-term investment plan for whoever's doing the planning. Reliability was and is a capital-intensive endeavor. I personally believe that that's the regulatory compact and why it exists. And so the idea is you want somebody who is making sure the lights stay on. Keeping the lights on has been something that's been expensive and requires long-term investments, lots of different strategies on how long those investments should be, how they get financed. But the nut of it is whoever's doing the planning is thinking about what their next investment is. They'll run the plan out a sufficiently long period of time in case there's a big investment that might take a long period of time to do. So classic example of that was a baseload plant. I don't see people planning baseload plants right now, with a few exceptions. So probably more relevant current example is transmission lines. Where do we need them? Why do we need them? How can they get built? Those type of things. So you're looking at, for the entity doing the organization is, say you're an investor-owned utility and you've got investment community and you're trying to attract this capital, so you have to try to convince the people you want the capital from that when you give me your money, I'm going to give you more money back. So you're trying to put a little meat on the bone of what am I going to invest in, so they have some belief when you're promising that they'll get their money back. So really, for resource plan, in the case of, say, Public Service Company New Mexico or all the IOUs in New Mexico, you do a resource plan every 3 years. You're required to look out 20 years. The lifetime of the IRP for usefulness to the organization might be 18 months. So when, like Mark did a great job of pointing out all the gas capacity that are in resource plans. I would say if you went and quizzed a bunch of the resource planners who are showing a gas plant 15 years from now, they'll tell you that's not going to get built. But it's in the plan just to solve the equation. So we don't really know what's coming down the road. The focus on the plan was the near term. And then, folks like myself, we had the opportunity to go out and engage with our customers, our stakeholders broadly on what the planning process is, regulatory requirement that is a public involvement process. I firmly believe that the public involvement component always made our planning better. So folks like me would go out and give a lot of speeches, very technical stuff. We would kill your desire to know anymore with long and boring speeches. But before we got to that point where we're standing there in front of you talking, we had a wide range of stakeholders within the company that had all of their input. And so sometimes, and one of my points here is you can get to a resource planning process that's kind of a least common denominator thing, and that's probably, I'd say, the worst version of a planning process, where it's just what can I get the minimum that people will agree on. When you're working in something like an investor-owned utility, you've got the operations group, the legal group, the finance group. All of them have a say. All of them want to add value to the process. So instead, you end up with this very dense, hard to understand kludge. A great example of that we saw yesterday, a gentleman from Duke in his slide presentation. I don't know if you remember his safe harbor statement slide. We all have one of those slides, or we all did, and if you actually read the slide, what it says is, please do not believe anything I'm about to say. And so where does that come from? That comes from the legal department. So you get up there and you're trying to talk about planning in a way that's very not conducive to building to the best solution. And then so my mantra through that whole process, how I would navigate it, was I tried to use the idea of don't buy something you can't sell. So internally, had to convince folks that, hey, we're talking about making changes, what range of change is available. When you take the plan and you go into the investor community, that's totally what it's about, is selling the company. All this, if you're in a regulated utility, then it's about selling these investments to the regulator, so the plan provides context, it helps folks understand it. So that's the nut of it, is you just, again, that helped me a lot, to just as a guiding principle, is don't buy something you can't sell. So then we get to the gap. So I already talked about, hey, we've got plans out there with tons of things the planners don't believe are ever gonna get built. I think one of the big things that communities involved want is a vision. They don't want a plan that's really only going to guide decisions over a short period of time. They want to see what things look like out to the future. So this has been covered very well in this conference, and I think we're going to continue to cover it, but we're at this very special moment where more things are possible than ever. We've talked about decarbonization, just talked about low-cost energy, customers have choice, devices are, Internet of Things. I mean, I could just go on for a half hour and throw all these buzzwords at you, but the sum of it is more is possible now than ever. And then more information is available, right? It's not just the Internet of Things, it's the actual internet. Folks can go out and design whatever solution they think makes sense. They've done their own work, they come into the planning process, and their solution might not be the thing you're talking about, so that's part of the gap. A good example of that came up this morning, where you get these proof of concept bids. It's relatively easy to access the process and to do something like that. And then again, more access to the process is possible. Publicly driven stakeholder, you got to get out there, talk to people. Models are available. We all have computers. Frankly, if you can play Call of Duty, then your computer is good enough to run a planning model. So there's just, Mark told me about the magic of gigabit internet access. So these are all things that we all have access to. So it's not, planning used to be kind of an exclusive club where not very many people had the resources and the tools required to do it. That's not true. So I don't know, I was showing my age here. I don't know how many of you folks are Monty Python fans, but the whole thing gets you to the point where if you're the planner up there, you feel like one of these Gumby guys, and we are here doing planning, and that's how it feels when you're at the front of the room giving that speech. You get the correct reaction back. Process isn't great. So just as my call to action coming out of this, just lay a couple of proverbs on you, is it's important to bring this gap together, because one of the things that we talk about at Western Resource Advocates is, if you want to go fast, go alone. If you want to go far, go together. So we're at a moment where lots is possible, making change is necessary. So if you want to go far with your change, you need to have a process that brings the stakeholders with you. Trying to just succeed to navigate the internal bits of how do you get to the public face part of your plan is probably the go fast approach. It's not the go together approach. And then the other is just a John Wooden thing in terms of playing basketball. He says, you know, be quick but don't hurry. So I think that's the ethic that that we should engage on in planning, and if we're a stakeholder, we should respect that process and try to help. If we're planners on the inside of a company, we should take that on, which is you got to be deliberate in what you're doing, but you have to do it quickly because, again, the window's open and we have to make some changes. So that was one of my human concepts. The other was, and we've already talked a little bit about this, is inertia. So for me, inertia's got two definitions, both very relevant to what we're going on here. You've got the human being definition of inertia, which is it's a tendency to do nothing or remain unchanged. But then you also have the physical concept of inertia. So we're getting into a world where this planning conversation I was talking about, you go to your system operator and say, hey, exciting, people are changing how they're using electricity. Your job's getting harder. And then you say, oh, and by the way, I'm going to take away the tool that you like the best in order to do your job. So when you're getting rid of something like a coal plant that has a lot of spinning mass and inertia, it helps with balancing the system. But the human being that's involved is saying, you can't get rid of that because I'm going to have to figure out a new way to do my job. So again, that goes to this whole concept of be quick but don't hurry, is you got to respect everyone along the way. And so I guess I'll just leave it at that. I hope to, again, I decided to take a take that wasn't very technical, looking forward to the discussion, and hopefully that some of this rang true to you, and if not, I'm going to be here the rest of the day. I'd love to hear your point of view. Thank you.
Thank you, Pat. Our next speaker is Angie Bond-Simpson. Angie is the Manager of Resource Analysis and Planning at SRP. Her team utilizes production cost and cost modeling software to forecast system dispatch and analyzes industry trends to determine possible challenges with new generation choices and plant retirements. Angie received a bachelor's in geology from St. Louis University and a master's in geology from Arizona State. The floor is yours, Angie. Thank you.
Thank you. I'm just curious, a little audience participation. I've been at SRP for my whole career, so I have a little bit of a sheltered perspective. How many utilities are out there today? How many of those are public power utilities? How many are vertically integrated? Okay. All right, good. So I'm not as alone as I thought I was. That's good perspective. So that's the point of view that I'm presenting today. So just a little bit of background. SRP is a large public power vertically integrated utility. We're also a balancing authority. We have about 1 million electric customers. We also serve about 1 million acre feet of raw water to the central Arizona area. Our load is in Phoenix, mostly. We have about a 7,300 megawatt peak in the summertime. Who's been to Phoenix in the summer? Yeah, there's a few poor souls. 118 degrees, right? 120 degrees summer peak. We serve those through generating resources that you can see on this map. So Navajo Generating Station will be retiring this year. That's the largest coal facility west of the Mississippi. We also, today we currently have about 3,000 megawatts of coal online. And we have some coal in northern Colorado and the Four Corners region. And we have ownership of Craig Hayden and Four Corners. Those are participation plants. And then Coronado and Springerville are wholly owned by SRP. We have a lot of gas generation located close to our load, combined cycle combustion turbine. We also have a diverse supply of renewable resources. One wind project, Dry Lake Wind, located in northeastern Arizona. We have the benefit of having good hydro, SRP hydro, located close to our load, and allocations of federal hydro along the Colorado River. We have a participation in a nuclear facility, Palo Verde, and we have biomass, geothermal, PPAs, and solar. So when we look at adding new resources, one of the things that we try to abide by is this new carbon target that we have. In 2035, we are trying to reduce our carbon by 62% from 2005 levels. And that's an intensity of 550 pounds per megawatt hour. So when we look at those carbon reductions, coal retirements are in there, but also adding renewables. Solar is our best bet. It's the cheapest. We don't have access to good wind in central Arizona. Geothermal is mostly in the Salton Sea for us, and we've already maxed out a lot of that opportunity as far as transmission goes. So solar's where it's at for Phoenix. Probably not a surprise for anybody here. I'm going to try to keep the presentation brief and try not to be too stream of consciousness on this. I can appreciate the "my brain hurts" statements. I usually say my brain's on fire. There are several things on a regular basis that keep me up at night. I joined the resource planning part of SRP about 7 years ago, and it was relatively quiescent and boring, and it was a great time to learn resource planning at the time. So our SRP forefathers, I guess I'll say, did a great job with our existing resource mix. And so planning for summer capacity was a breeze, right? So this is the look of how we planned 7 years ago, and 90% of what we were concerned about is really meeting that peak need. So this is our peak need. We're lucky in Arizona. People want to move there and live there, and so we see load growth forecasting. We are forecasting load growth about 2% per year. So we stack up all of our existing resources, all that coal, gas, renewables, and we didn't really expect to retire a whole lot back then. Then we'd have some future resources in development, and then we'd have this big giant need, 10 years out or so. And so that was our job, is what are we going to look for to fill that need on a capacity basis. So things have changed a little bit since then. We are now more concerned about what our neighbors are doing, and I'll talk about that in a little bit. So SRP has done a little bit of planning and isolation of we are cost to serve. We have retail customers. Wholesale transactions are icing on the cake for us. But we can't really plan in isolation anymore. What our neighbors do and their resource decisions affect us, and what we do affects the region. And so that's a very important component. We also have to look 8760 a little bit closer. So we had an emergency event this year in April. So our, hey, build to meet peak and you'll have those resources available at any time of the year didn't really work out so well for us. When we look at that decarbonization goal, and perhaps we can have existing assets online for capacity resources only, that makes us have to plan with our operations folks, with our kind of plan more holistically, really, to make sure that we're planning out outages in the right time and that all of those resources are available. One of our big concerns is also with the capacity value of intermittent resources, and I would argue, and I'm happy to argue later on too, that any resource that's not available 24/7 has a reduced capacity value to SRP. And so we are spearheading a lot of effective load carrying capability work. We're trying to figure out how much solar does to our portfolio as far as a ramping need, intermittency need, the flexibility need, and the value of that. And a lot of other fun stuff. Regional markets, that's always great work too. So a lot of that stuff has been done in isolation, but they actually overlap quite a bit, right? And the needs of the planning are today. I have 17 amazing people on my team that are wicked smart, and they can do great work, but they can't do great work high priority, fast, all the time. Like, they have to have a break, right, or there's going to be a revolt. So the needs are, for a long-term planning organization, sometimes we put out a lot of fires. I just briefly want to touch on something. Oop, went too fast. I'm going to go back. I'm just going to bounce around here probably. So one of the ways that we value new resources is through our electric price forecast. So if we look back in 2015 to 2016, this probably shouldn't surprise anybody. We're maxing out around $70 a megawatt hour for Palo Verde. If we move forward, you start seeing things happening in the region and you're getting some price spikes, right? Summer price spikes, not really huge surprises there. Move forward and you're starting to get more price spikes in the shoulder months, which is a little weird. And then you add this year on and you have some events that are happening in February and March. So if we're valuing resources, valuing solar, valuing flexibility, I would argue that one of the fundamental things that we have to consider is a really robust electric price forecast and figuring out how to incorporate volatility in there. And so that's one of the reasons that we started to pursue work with Ascend, is to really get a good handle on that and to try to answer that question. And then we've talked a little bit about IRP. So SRP is a little bit different. We do a strategic IRP. We don't have to pick a plan. We try to look at scenario planning and different decisions that we can make and different values of uncertainty. We pick bookends and try to interpolate between those bookends. And so in 2017, we had a process where we invited over 90 stakeholders. It was very resource intensive. We started in 2016 with the analytics, ended with the report in 2018, which is publicly available, and went back and forth several times with different analytics and different versions. But we really came up with these strategic resource directions. So what did we have in 2017? And then that helps us implement our resource plan going forward. So probably nothing groundbreaking or earth-shattering for you guys. We need to divest in coal generation, figuring out how to help out the communities that those generating facilities are in. Look at more renewables, and when they are cost-effective, add those to our portfolio. We have a lot of customers that are trying to green up their own energy, that have their own goals. Participate in regional markets, understand battery storage. So we have pilot projects with battery storage technology. Solar plus storage plant worked very well for us this summer. Our standalone battery was unavailable in June. That is not going to work out on a larger scale for us. And then really look at R&D projects. So as a public power utility, we're not going to be serial number one on any technology. We really want to understand how robust all technologies are that fit into our power portfolio.
All right, thank you, Angie. By the way, I think we have a few bonus slides if you want to skip through those. Our next speaker is Dan Steinberg. I've known Dan for a while, since I had a relationship with NREL back in my professor days. But Dan is a senior researcher and manager of the Economics and Forecasting Group at the National Renewable Energy Lab. Daniel's expertise is in policy design and impact analysis, energy system modeling, and econometrics. His current research spans a broad range of topics, including clean energy policy and the associated implications for the evolution of the power sector, electrification of end-use sectors, and renewable grid integration. Thanks, Dan.
All right. So I thought I'd talk a little bit about power system planning and sort of evolution of the power sector from the national, at least the lower 48 states in the U.S. perspective. A little bit of a broader perspective than just individual utilities, but I think valuable nonetheless. So this first slide shows results from our forthcoming 2019 NREL standard scenarios analysis, which is a report and analysis we put out every year that looks at alternative future scenarios in the power sector. This is the mid case, so this is by no means our prediction of the future, but rather a scenario that assumes kind of current forecasts for fuel prices coming from the Energy Information Administration, as well as generation technology costs and performance assumptions from NREL's annual technology baseline. So the themes here probably aren't new to anybody in this room, but basically what we're seeing are two key things. One is rapid growth in contributions to both generation capacity from renewables, largely in the form of wind and solar, and then sustained contributions on the generation side from natural gas. So perhaps a bit of a contrast to Mark's presentation earlier, but this is not the only scenario we look at. Here is a slide that shows the particular contributions towards generation and capacity of some of those key technologies, in this case, gas, wind, and PV. So although there's a wide range of outcomes that we could see depending on how some of these market drivers evolve, what we do see are some main trends. Namely that across all of these scenarios, we're seeing increased contributions from wind and photovoltaic technologies, right? That's irrespective of how variation or magnitudes of gas prices evolve by mid-century, how generation technology costs evolve. Gas also continues to be playing a big role, kind of irrespective of where things go. We're not alone in making this recognition. This compares the reference case scenarios from some of these power sector evolution studies from a number of different institutions, National Renewable Energy Lab, Bloomberg, the Energy Information Administration, and the International Energy Agency. And kind of across the board, they all use different models, but across the board, they're seeing substantial growth in renewables, some of them a little bit more bullish, some more bearish. But across the board, we're seeing big contributions from renewables. Whoops, let me back up one. So what does this mean? We're seeing this growth in renewables. I think there's two key observations here that we have to think about with respect to power system planning and how things might change going forward. One is that renewables have effectively zero variable costs, right? And so I can't remember who it was that showed the merit curve effect, but basically we have a downward impact on wholesale electricity prices. And so when we look at 2050 here, under a set of scenarios, the mid-case scenario in the top left, a high renewable energy cost in the top right, so lower deployment of renewables, and then low renewable energy cost in the bottom left. This is the percentage of hours by region that we're seeing zero or negative energy prices. And of course, as we're seeing increased deployment of renewable energy, we're getting a lot more hours with these zero prices. So this has implications for how are different types of technologies going to recoup their costs? What revenues are they going to be getting? Obviously, if this is the case, they're going to be receiving less revenue from energy markets. The other key thing that we just heard about a little bit is that the capacity credit, the contribution that variable generation sources make towards the planning reserve margin declines as you increase in the penetration, right? So when you first put your first megawatt of PV on the system, that's basically coincident with load. You get a lot of contribution towards those peak load hours. But as you deploy more and more, as we've seen in CAISO, you're shifting the peak to those evening hours, the sunsets, you don't get that same capacity credit. So as we're deploying these for their energy value, how are we actually maintaining those capacity resources going forward? So I apologize, this is probably a little bit small to see, but what this is showing on the top row here is what is the actual nominal capacity that's being deployed under this mid-case scenario. And then the middle and bottom rows are showing what is the actual contribution towards that planning reserve in both the summer and the winter. And what you see is despite the fact that you're deploying, I think in this case it's close to 1,000 gigawatts of combined wind and solar, the actual contribution to that planning reserve is relatively small in both winter and the summer. In the winter case, it's quite low. One other thing that you'll see popping up there is substantial contributions from storage. But really, where are we getting that capacity still in that mid-century scenario with much higher deployment of renewables? We're still getting it from the thermal fleet. We're still getting it from the remaining coal, the gas plants that are still online, some of the remaining nuclear, and then smaller contributions from storage, wind, and PV. So what does that mean in terms of how are the revenues that different types of technologies are actually recouping over time? And so we have two snapshots here in time under the same mid-case scenario. The left is in 2030, the right is in 2050. And this is by technology, how is the cost recovery actually happening for these individual technologies? This is a modeling result, so in this perfect market world, every technology that's deployed is getting perfect cost recovery. It's a linear program. We'll talk a little bit more about that in the final remarks. But basically what you're seeing is most of the technologies, with exception of natural gas combustion turbines, CTs, are recouping most of their revenue through sales of energy, right? Energy sales. There are some contributions from that planning reserve for capacity payments, basically. But as we move forward in time, we have that downward pressure on energy prices from the zero variable cost generation. So that revenue actually declines across all technologies. And what we're seeing is more of that revenue is actually coming from capacity payments. Now, I think the interesting thing here is, this, much like just about every capacity expansion model, every investment model that's used for planning, is a linear program. What does that mean? It means that we represent a set of needs that need to be met by the model. So we represent an energy requirement, we represent a planning reserve requirement, and we represent a different mix of operating reserve requirements. And of course, you have to meet load, and that's tied to the energy requirement. So what happens is the shadow prices on these constraints rise to the point where you're actually getting investment by different technologies to provide these different values. So we're modeling this perfect market world where we have an energy market, a capacity market, and an ancillary service market, and there's also a rec market shown here. And so what we're seeing here is more of that revenue is coming from the capacity market. But P.S., they're not perfect capacity markets in the real world. And so as we're modeling these things, what does this imply about where do different electricity markets and the services that they require need to evolve to maintain a reliable power system? This is one look at what that market would look like, and we need to be able to evaluate how those different market structures will ultimately impact the revenue and the potential for cost recovery. All right, so what does this mean for modeling future power systems and associated markets? First, a couple high-level observations. With increasing penetrations of variable generation, there's a couple of things that will likely happen. One, energy revenues are likely to fall. Energy prices are going to go down, and so their energy revenues in general are likely to fall. Capacity revenues are likely to rise if you're actually getting paid what the value is for that capacity. And then operating reserves, depending on the operating reserve and exactly what happens in markets, that could change. We saw in Andrew's presentation earlier what's happening to the down regulation revenues in CAISO. Those are going up. Is that going to be maintained? My personal opinion is probably not, as we get to a world where you're getting some of that provision of those regulation services from variable generation at basically zero cost. So to appropriately value these services, models need to capture endogenously a few things. One is really important, that's the declining capacity credit of variable generation and storage. And on top of that, their interactions, right? So I think everybody's seen the duck curve, everybody knows that, it's very intuitive. But as you start to add on storage, how does that actually change the capacity credit of solar? And how much of that capacity credit is actually shared between solar and storage, or how much deserves to be put on the storage? So as we're moving forward in time and we're thinking about these different assets, who actually gets that capacity credit if it's a different developer that's developing the PV and a different developer that's developing the storage? The other piece is the increasing rate of economic curtailment. I have economic there in parentheses because yes, this reduces the value, the energy value of variable generation assets, but a certain amount of it might be economic. You still might deploy a PV system expecting 15% curtailment just because it's still so low cost. If those costs keep coming down, we're likely to see higher levels of curtailment that are still the most economic way to meet load reliably. What's the interaction with storage? How can that basically benefit your system by reducing your level of curtailment, being able to use more of that energy? And then what's the ultimate role of demand side and supply side flexibility in terms of meeting all the needs of your system? Okay, a couple of higher level comments about planning here. So there's a range of models out there that handle some of these issues reasonably well. The regional energy deployment system that we developed and that was used to generate the results that you saw here, which is also now publicly available, by the way. And a handful of other models are tackling this problem fairly well, and I think do a pretty good job at it up to moderate penetrations of variable generation. But when we start to look at systems that have 80, 90, 100% penetrations of variable generation associated with goals in California, Pacific Northwest, New Mexico, wherever, their models are still struggling to value these things appropriately. What is the capacity credit of a 2-hour battery versus a 4-hour battery versus an 8-hour battery when you have 95% wind and solar penetration? These are questions that are very hard and are really nonlinear in nature, and so hard to capture within a modeling framework. But our system is evolving so quickly that just thinking about individual systems and then jumping straight to unit commitment and dispatch modeling to evaluate a new system, in my personal opinion, is a bad way to go, because you really can't integrate all that information given how rapidly the power system is evolving. So you really do need to use an investment model. The other piece is that the current state-of-the-art of capacity expansion models aren't capturing the market dynamics well, or the market design questions well, right? Effectively, they're all assuming a specific market structure, one that has an energy market, a capacity, long-term capacity market, and then a set of operating reserve markets. That is not the case across the board here in the US, and it's unclear what the future is going to hold. So that limits our ability to analyze the values of different technologies in different paradigms, and that's a key observation. And the other piece is that currently we can't actually evaluate in a simulation world how these different types of markets create different incentives. We can't identify what is the, quote, best market setup, what's the most efficient market to most efficiently procure all the resources you need to maintain a reliable power system. And so getting to maybe some of the questions we're going to hear from Brent, I think there's a lot of work yet to be done to build the right set of tools that can really inform our understanding of how the power system and the markets supporting that power system are going to evolve from present day out to mid or late century. And I'll stop there.
All right, thank you, Dan. I really like the way this kind of bookended, because Mark started off saying, look at all these thermals that we can replace with clean energy. And Dan kind of finished saying, we still have to maintain reliability, and these clean energy portfolios aren't necessarily going to give us the capacity. So I want to kind of open with a question about, to everybody, how should we think about system reliability and clean energy portfolios as a substitution, or as a potential substitution for thermal generation? And can we really get the capacity that we need and the reliability that we need, particularly as we look to high renewables futures?
Do you want me to, excuse me, do you want me to go first, Brent?
Feel free to start off.
All right. So I have a couple different answers to that. One is the point of view that we were taking in the study that I laid out was really that of the investor in projects that are proposed for construction today. And the overarching finding is if you expect those projects to run for the next 5-10 years, like you see projects run, combined cycle projects run today, you have another think coming. They are going to get outcompeted by cheap energy from renewables and increasingly valuable capacity from batteries on the margin of the present system, right? The other answer is some of the, so Dan, your presentation, I understand NREL is somewhat, has a great variety of tools to deploy, but you're limited in the scenarios that you can look at. For example, climate change mitigation scenarios.
We got those in there.
You got those in there. So once you constrain the carbon in the system, the situation looks very different. I got back late last night from New Jersey, where we just presented preliminary public results of the state's integrated energy plan using a cutting-edge capacity expansion and dispatch model that a partner of ours has developed. And we saw the same growth in combined cycle capacity within New Jersey to maintain reliability. That growth didn't start till 2035. And dispatch from those assets went to nearly zero by 2050 when the carbon constraint was most binding to meet their 80% by 2050 reductions. So until you look at the full range of options and you consider as an investor today, what is the range of policies that's going to constrain how much I can actually run this new gas plant, until you really internalize that risk into the billion-dollar check that you write for a new combined cycle asset, you don't have a complete picture of the real financial risks associated with that decision. And some of the leading edge work that's coming out across the research space and across the utility space, because utilities clearly, some of them are in this room, are already internalizing that within their IRPs, it's showing the same thing. You might need some new gas capacity to back up the existing fleet's reliability services, but generally that need doesn't show up for 10 years, and it doesn't run very much. So I'll agree with Dan on this point, that you need to start thinking about how to compensate those resources on a capacity basis, on a multi-day capacity basis, when renewables plus current batteries just don't cut it, versus what they are today.
And I would love, Pat, if you could weigh in on kind of the stakeholder management of communicating to an environmental group the need for thermal capacity, even if it's at low capacity factor, and the communication to customers to sort of understand that we need this billion-dollar asset that doesn't run, except for rare occasions or something like that. How do you manage that stakeholder engagement and communication process?
Yeah, I'll take that question, and also I kind of want to circle back to the initial question, but in terms of managing stakeholder process, it's this weird blend of you have to be as direct and simple as you can be without underestimating what it is you're trying to do. So my idea had always been try to get the right denominator. So when you're talking about if you are promoting a gas resource for capacity reason, then to the environmental group, it's the reason Mark just said is this is not going to run very much. So you should be able to show that on a system basis, the tons of carbon are going down. And so if you're not showing that while you're adding your gas resource, you're probably, first of all, not going to get the support of an environmental organization. But second of all, that's the way you have to look at it, is make sure that you're judging the solution by the most important thing, which in this case would be reducing carbon emissions. And then back to the initial question, I'm not all that concerned about capacity being an issue going forward, because that's like the one thing on reliability people seem to understand. I think another example of a reliability issue would be as we're moving to this inverter-based world. Going back to my inertia slide, you've got these big hulking things that are setting the beat for the whole grid. When you start turning those off and you're running on inverters, you can lose the beat. And so when that happens, things start operating on their own, and then they might start crashing into each other. So one thing I love about the world we're in now is, power operations and planning used to be the domain of mechanical engineers, but now that we're in this renewable world, it's the civil engineers that are in charge, right? So, just forgot where I was going with that joke. But so anyway, okay, if you're a civil engineer, you saw the video of the Tacoma Narrows Bridge collapse in 1940. So that's the kind of thing, to circle back to your point, is that's how you illustrate something for a non-technical broader audience, is that, I can't really show you what 60 hertz looks like, but I can show you what failure due to harmonics looks like. I've got a great video for that. So you got to be creative, and you have to stay true. While you're being creative, you also have to be true to the actual physics of what's going on. So that I think is the talent and the challenge of resource planning.
Angie, do you want to weigh in?
Yeah, I'll just say that maybe, it's like that's my answer to everything these days, is maybe we'll figure it out. I know we'll figure it out, right? But we at SRP are beholden to our customers. They really like power. They want reliability. They want to keep the lights on, right? We are really proud of our SAIDI and SAFE scores at SRP. So when chemical storage, battery storage comes to fruition and we've got everything figured out, we'll totally adopt it. But we're not ready to negate the experience we had with our pilot projects.
To kind of bounce off of that note about experience, do y'all have, and by y'all I mean the whole panel, y'all.
Y'all.
I went to grad school in the South,
y'all.
So there's multiple uses of y'all. Do y'all have any concerns, or do you think about or worry about the pace of change happening faster than our ability to build experience? So for example, if you have a 1 in 50 year weather event and you have a rapid change that happens over the next 20 years and you don't see this 1 in 50 year weather event, and now you're at this point where you think you've got everything handled, and now this 1 in 50 year event comes that you don't have any experience with, didn't know was coming, and now you have some system impact like, I don't know, some weird weather event. I know DOE is actually starting to look at some of these questions. Do you worry about that? Do you think about that? Do you have concerns that the pace of change can come faster than our ability to build experience?
I have a quick answer on that. So I think it's a feature, not a bug, right? And it cuts both ways, both with existing incumbent technology and grid architecture and the future that we might be going towards. So on the first part, it's a feature, not a bug. This is the forcing device that we're seeing from extreme weather events in particular, driven by climate change, is a catalyst for folks to think differently and folks to incorporate that into their resource and grid planning. And it's lighting a fire, if you will, under utility innovation. And then in terms of it cuts both ways, I think we're seeing with what's happening in California right now and what's happening in other parts of the country that there is the extreme events, this pace of change, it's threatening status quo and it's threatening business as usual, and it's causing the right questions to be asked about what's next, but it doesn't necessarily preclude them. So I think it's hard to go through as an industry, but it needs to happen.
Yeah, I would say it's not a fear, it's a reality. And the example is your regulatory staffs. When we came through this period where we were building all these plants that were shut down, there were some very talented, dedicated baby boomers that were young folks on those staffs. They're hitting retirement age, or they don't want to face the fact that, hey, a plant I helped to create is now getting shut down. So they're leaving the system, and we've been slow in filling in behind those folks. So I think that's something we see across the states we work in, is the regulatory staffs are not as experienced at the moment, or maybe even understaffed at the moment. And so that's an important element of making these changes happen in a world where investments have to get approved to move forward. And I share Mark's point of view on this California event. I mean, that's a spectacular failure of the regulatory compact. So is that a one-off, or is that a harbinger of things to come?
I think, I've been doing much more sort of applied work recently, working directly with utilities on both coasts. And I think my observation is that I think we have solutions for a lot of the problems, but I think as Patrick pointed out, that's not how we do it right now. And so there's this huge social element to how do we get large groups, large operational groups to sort of adopt change, and what are ways that we can create more confidence in, you can actually operate your system this way reliably, just take some changes in operational practice. I think there are also some technical hurdles, if you're operating a transmission constrained region and you need to import a lot of renewables to get to your goal, is it actually feasible to upgrade or build new transmission pathways to get that energy to those locations? And so I think that's some of where the rubber meets the road technologically, but in some cases that's also a social hurdle of NIMBY issues and things like that. So yeah, I think it's all achievable. It's just it will take some careful thought, and I think we can increase the speed at which we adapt if we think a little bit more about the social aspects of that change.
Yeah, I think it goes back to kind of a workforce issue as well. I agree with most of what's been said up here. You heard I have a science background, but what I find with our existing workforce is there's a lot of gut feel, right? Like, my gut tells me this. Yeah. And with our workforce, not only do we have to have super smart modelers, we have to have people that understand engineering and economics. We also have to have people that can communicate and motivate, right, too. And so we do all of this analysis. It's our job to present it to those people that have the gut feel to try to influence change. And that sometimes is the biggest hurdle we have, aside from all of the actual science things behind it.
So Do you think that there's a possibility that the way that we think about reliability will shift in the future? In a high renewables future, do you think people will accept a lower level of reliability in exchange for lower carbon emissions, or that there would be different potential rate classes with different priorities for load shedding? Do you think that the way we define and think about reliability might evolve in a high renewables future?
I don't. I think if you're an electric customer, reliability is a problem solved. And so any backsliding or less reliability is a great example of what people were talking about yesterday. We have to make sure we don't screw this up. And then on the other side of the fence, you know, there's these conversations you have with system operators. We would joke about or be reminded of that Few Good Men movie where a system operator takes the "you can't handle the truth" approach on how you communicate what's going on behind the scenes. So not only do customers think it's a given and it's going to happen, I don't care, we're going to meet all our other goals, and that's what's going to be true. The folks who are delivering it aren't very sharing in what the challenges really are.
So I generally agree. I think the one place where there might be a window is with large industrial customers. I'd be interested to hear Patrick's response to that. But if you have a huge electricity bill, you know, and you can have poor power quality or less reliability, and I'm not saying that you just randomly get turned off, but something looking like somewhere between reliability and demand response, there might be something there. But I agree generally, residential, commercial customers, you want power.
Yeah, and I think for the industrial customers, that's part of this. Way more things are possible than ever before. Back in the good old days, they kind of had to carry their own water on reliability. We got better at delivering reliability, so there was some backsliding there. But I think the concept of a microgrid, that's what a hospital's always been. I think that rides again.
But I want to take a chance to remind folks that we're talking about reliability on a power supply planning panel, and 99+% of reliability issues come from the wires, not the generators.
That's right.
Right? So my short answer to your question is no. This also isn't necessarily the place to be addressing it. I think that the more pertinent place to be addressing it is in some of the grid planning that comes generally after the supply planning. And again, looking back at what happened in California last week, that's the reliability challenge that is, you know, one of the defining issues that we will have to address as an industry moving forward. That has nothing to do with the generators connected to the transmission system.
So SRP's got some retail interruptible customers, and we've been somewhat successful with being able to call on those resources when we need them. But my guess is that we're going to put a lot of time and effort into designing programs that you might get some sort of reliability hit if you want more carbon, and perhaps they work for a year, but behavioral observations, people tend to they're not persisting resources, right? So you might have them for a year, but people decide that they actually like reliable power. So I think that we might put a lot of resources and time and effort into doing something that's not going to persist long term.
I noticed that load flexibility was part of your clean energy portfolios. So there's kind of a fine line between load flexibility and forced load flexibility, for what it's worth.
Well, one of those you get paid for.
Well,
one of them doesn't make you angry, and the other one does. So I think we as a demand response industry in this country have figured out that line pretty well, and we're only getting better at it.
Yeah. I was assuming there could be rate classes where you pay a lower rate and you accept a higher risk.
Perhaps.
Potentially. 10 years from now, what do you hope will be different? What do you think will be different? And what's the biggest thing you'd like to see change in the power planning process? So what do you hope will be different? What do you think will be different? And what do you want to see change?
Can we start at that end?
Start whoever wants to jump in.
I'm unprepared for these questions. What do I hope? I hope every utility uses the capacity expansion model and thinks about specifically about calculating the capacity credit associated with variable generation. What do I think will be different? I think the latter of that will be probably be true, the former may not be. What was one thing you'd like to see change? I don't know. Yeah, I guess just, continued pursuit of analytical rigor. I don't know. Yeah, I don't have a good answer. Sorry, Brent.
So I hope that 10 years from now we're sitting in this room or hotel, I don't know, and laughing about all the stuff that we talked about today, right? I hope that it's all figured out and that we have experience and that there's some certainty in a lot of the uncertain variables we're looking at today. What do I think will be different? I think there'll be a transformation 10 years from now, and we're just going to have to figure it out. And what I would like to see in the power planning process is that more education, right? We flip the lights on, and when you realize how the sausage is made, it's like, this is actually pretty incredible, right, that this is even happening. And so delivering reliability is a double-edged sword. When you deliver reliability, people expect it and might not necessarily know what goes into it. But I would really love to see more education and outreach efforts to our customers and to stakeholders on a regular basis.
What do I hope will be different is I hope there will be a good regional market in the West within 10 years. What I think will be different is I think there will be an electric Ford F-150. So we're well on our way to not just decarbonizing the electric grid, but also decarbonizing the transportation sector. And then what is the biggest thing I'd like to see change? I mean, I think that was kind of the whole point of my presentation, and echoing what Angie just said, is that the phrase I've always used is we need to elevate the conversation. Not as elegant way to say that is I've upped my standards and now up yours.
So we don't have 10 years. So I'm going to answer the question for 1 year. If we delay the changes for even 5 years, we've locked in $100 billion of capital and 100 million tons of carbon per year in emissions from new assets. That's not a good thing, right? So in 1 year, I hope that everyone will have taken the lessons from the previous panel on clean energy all-source RFPs and use those to really inform the planning process going forward. That's the low-hanging fruit of avoiding some of the mistakes that we believe are coming if we don't do that. I think, as Pat said, what I think and hope will be different is we will have taken that success and made the problem bigger, right? We will have not just stopped at the IRP. We will have not just stopped at the electric system. We will have considered what the implication of electric buildings, electric cars means in the context of a much steeper reduction in economy-wide CO2 that requires those actions and making that problem bigger.
All right, thanks. We're out of time? We're out of time. Okay, let's thank our panel.
Excellent.
I wish I could have shown the Jersey slide, but I couldn't. Sorry.
Excellent. Thank you, everyone. Appreciate your participation.